Hi, Science Quickly listeners. I'm Bree, Associate Books Editor at Scientific American. If you love the stories we share here on the podcast, over at scientificamerican.com, there's a whole world of stories waiting for you. You'll find my book recommendations and curated reading lists, along with deeply reported articles and science news that helps you stay informed, curious, and connected. I love finding books that push me to think about the world in new ways and hope our stories do this for you too. And if you're in New York, join me on November 20th at 7:30 p.m. at Greenlight Bookstore for a panel discussion with some of the incredible authors we recommended this year. Now, if you believe in the power of great science storytelling like me, please consider subscribing to Scientific American at scientificamerican.com/getsciam/sciencequickly to help support everything we do.
For Scientific American Science Quickly, I'm Rachel Feltman. You don't have to pay much attention to the news to know that climate change is causing Arctic sea ice to melt, and to understand that this is a huge problem. Ice reflects sunlight, which helps keep cold places cold. Warmer weather means less ice, but less ice means more heat from the sun, which means it gets warmer, which means there's less ice, and the sea level keeps rising and rising. It would be great if we could cut this problem off at the source by dropping our greenhouse gas emissions, but we're not exactly making great progress on that front. In the meantime, what if we could just make more ice? It might sound silly, but some folks in the polar geoengineering space are making a very serious attempt to do just that. To get the inside scoop, I'm handing the reins over to Pulitzer Center Ocean Reporting Fellow Alec Loon. He's the author of a feature on the subject in Scientific American's June issue, and today he's going to take us along on a trip to the Arctic.
I'm snowmobiling out onto the sea ice from the Inuit village of Cambridge Bay in Canada's Arctic archipelago. It's negative 26 degrees Celsius. That's negative 15 degrees in Fahrenheit. The blasting wind makes it feel far colder. My goggles are freezing over, and my thumb is getting numb on the throttle. But this is actually warm for Cambridge Bay in February. It's been the warmest winter in 75 years, and the temperature at the North Pole even briefly went above freezing. In front of me, a local Inuit guide is towing a sled full of team members from the UK company Real Ice to a point about 7 kilometers from town. Scientists say as early as the 2030s, the Arctic ice cap could start melting away completely in the summertime, raising temperatures around the globe. Real Ice hopes to stop that by artificially freezing more sea ice. It's one of several geoengineering projects trying to save the world's glaciers, ice sheets, and sea ice. Some scientists think it's ridiculous, or even dangerous. But Real Ice co-founder Cian Sherwin says we no longer have any option but to try.
So right now I'm about to start drilling that 10-inch auger hole for the pump.
Cian was part of a student group at Bangor University in Wales that built a re-icing machine after they saw a TV documentary about the melting Arctic. In 2022, he co-founded Real Ice to try it on a larger scale. The ice outside Cambridge Bay is more than a meter thick. Cian drills a hole in it with a long, battery-powered auger. If you've ever been ice fishing, you've seen this kind of tool. It looks kind of like a jackhammer, only with a giant rotating screw rather than a chisel at the end. Inuit guide David Kavanagh widens the edges of the hole with an ice saw, and the team puts a wooden box around it. Cian lowers an industrial pump with a long hose through the hole. He plugs a cable into a battery pack, and seawater starts pouring out of the hose, creating a brilliant blue pool on the sea ice.
Where that flow rate isn't as strong, the ice or the the water acts almost like lava, becoming thicker in viscosity, and ice formation starts to begin almost instantly.
Sea ice freezes from below, where there's water that's just under 0 degrees Celsius. But once the first layer of ice forms, it partially insulates that water from the freezing air above, which can be as cold as negative 50 degrees Celsius. So the thicker the ice gets, the slower it grows. Real ice is trying to bring the water up to the cold air by pumping it on top of the sea ice. After about 3 hours, the team comes back to take the pump out. The pool of water has congealed into an electric blue slush, like a gas station Slurpee.
So by the time we return here now tomorrow morning, this will already be frozen. New sea ice. New sea ice. Or a new layer on top of the sea ice.
Releasing small particles to block sunlight is probably the most common geoengineering idea. It's also highly controversial because it could affect weather, like rainfall. Mexico banned solar geoengineering after an American firm released balloons full of sulfur dioxide there. A city in California recently halted an experiment spraying sea salt particles into the air. In May, the UK allocated about $75 million to geoengineering research, becoming one of the first countries to fund outdoor experiments in this field. One experiment will launch balloons to test mineral dust that could someday be released into the atmosphere to block sunlight. Another 2 will develop nozzles to spray sea salt particles, including, potentially, over Australia's Great Barrier Reef. But the largest grant in the British program, about $13 million, went to a research group that includes real ice. It also includes the Dutch company Arctic Reflections, which has been testing giant pumping platforms to thicken sea ice in Svalbard and Newfoundland, Canada. Polar geoengineering trials have been moving forward in other places too. A U.S. nonprofit has been scattering tiny white clay granules to reflect more sunlight away from glaciers in Iceland and the Himalayas. And a Scandinavian project has been testing materials for huge underwater curtains to try and stop warm water from reaching the underside of Antarctic glaciers and melting and collapsing them. If it works, polar geoengineering, like sea ice thickening, could affect the entire Earth. Arctic sea ice is like a big mirror, reflecting up to 90% of the sun's radiation back into space when it's covered in snow. But ocean water absorbs 90% of sunlight. The more ice melts, the more ocean water warms. That heats up the planet and melts even more ice. The thick sea ice that lasts year-round has shrunk about 40% in the last 4 decades. If it starts melting away completely in the summertime, global temperatures could rise an extra 0.19 degrees Celsius by 2050. Last winter, real ice thickened about 250,000 square meters of sea ice. In the winter of 2027-2028, the company plans to thicken 100 square kilometers as a demonstration. If that works, the team hopes it could scale up to eventually keep Arctic sea ice from disappearing in the summer.
That targeting an area roughly 1 million square kilometers across the entire Arctic region could be enough to help prevent the loss of sea ice.
On the one hand, that's small. It's 1/5 of how much ice is currently left in the summertime. On the other hand, it's enormous, the size of Texas and New Mexico combined. Real Ice says it could be possible. All they'd need is 500,000 underwater drones. Real Ice has been working with the Sant'Anna School of Advanced Studies in Italy to develop a 2-meter-long automated drone. In a computer rendering, the drone has a pipe that folds out like a pocket knife. The pipe would be heated so it can melt through the sea ice from below and then pump water on top of it. Real Ice hopes to test a prototype by the end of the year. The idea is that something like 20,000 technicians will be working on onshore and offshore platforms, swapping out batteries so the 500,000 drones can keep thickening sea ice. The old batteries would have to be recharged with wind power or green ammonia or hydrogen. That would have to be brought in by ship, since the Nunavut region's grid is all diesel.
500,000 drones might seem like a large figure.
That's Andrea Ceccolini, a wealthy tech investor who is co-CEO of Realize.
We produce globally over 90 million cars every year. We also produce more than 40 million e-bikes.
But only about a few dozen underwater drones have ever been deployed under polar ice, such as the UK's $1.3 million Bodie McBoatface. The closest equivalent to what Realize is proposing would probably be the 3,800 Argo floats deployed around the ocean. And these floats only need enough power to measure temperature and salinity as they drift with the ocean currents. Craig Lee is a University of Washington oceanographer who helped develop low-power sea glider drones that operate under polar ice. I spoke with him on video call after I got back from Cambridge Bay. He says it wouldn't be feasible to swap out thousands and thousands of batteries every day in one of the harshest environments on Earth.
You need a revolution in how the vehicles are powered. Not going to happen on any battery that we currently use today.
He says keeping that many remote drones in good repair would also be impractical. Right now, the only way to deliver equipment to Arctic communities like Cambridge Bay is on a ship that comes through once a summer when the ice melts, or by propeller plane. The village lies in the heart of the Northwest Passage, the infamous sea route between Europe and Asia that took sailors 400 years to successfully navigate. The first thing I saw when I landed at the one-room airport was a stuffed musk ox, which looks like a bison with shaggy black fur, and a plaque about the doomed 1845 expedition of John Franklin. One of Franklin's two captains was confident they could get through the passage in less than a year. Instead, their ships became trapped for a year and a half in the polar ice that surges down the channel toward Cambridge Bay. The men abandoned the vessels, and eventually all 129 of them died of cold, starvation, or disease. Some resorted to cannibalism. With sea ice thickening, real ice is also entering uncharted territory. I wondered if abandoned ice-making drones would someday join Franklin's ships at the bottom of the passage. The first big question is salt. When seawater freezes, the salt in it is ejected and pockets of brine form on the ice's surface. Salt lowers the melting point of ice, which is why trucks spread salt on the roads in winter. If pumping seawater means that more salt remains on the ice during the summer, it could accelerate the melt and make the ice thickening largely pointless. So far, that doesn't appear to be happening. Out on the ice, Simon Woods, a London software entrepreneur who co-founded Realize with Kian, attaches a long red barrel to a drill and bores into the ice. He pulls out an ice core as long and thick as his arm and holds it up to the low sun.
Can you see them?
So those kind of little, just little lines in the ice.
Yeah, those are brine channels.
I mean, they're
The brine appears to be eating through the ice, returning the salt to the ocean. Snow is another wild card. The water pumped by Realize floods the crusty snow that covers the sea ice, freezing it solid. Have you ever wondered how Inuit people were able to live in igloos? That's because snow is actually a really good insulator. Simon drills through the ice and drops in a measuring tape with fold-out brass arms to measure its thickness. The team has added 20 to 30 centimeters of ice by pumping water and freezing the snow. But that's not the end of the story.
But what we're hoping to see later in the season is that exposing the surface so that there's less snow cover means that it's less insulated, improves the conductivity of the whole stack so we get ice growth from below. That's the really efficient part of the process.
yeah.
At the same time, snow is a better mirror than ice. Bare ice reflects about half as much solar radiation back into space as ice covered in snow. Real ice needs the snow to accumulate again in the spring, or the company's process could increase the melt rate. The animals living on the ice also need that snow to come back. Brendan Kelly, a marine biologist at the University of Alaska Fairbanks, used to be a polar science advisor to the Obama administration. Now he's advising Realize on possible consequences its plans could have for the ecosystem. With Brendan, I walk along a low ridge where two massive pieces of ice are pushing together. We see a patch of yellow snow. You know what that means. A few meters further is a dry green turd. Then we come to a small pit dug in the snow. These are traces of an Arctic fox, the fluffy white cousin of the red fox most of us know.
This. The foxes come in, marked and dug. He thought something was there.
That something might have been a ringed seal. These animals dig lairs under snowdrifts to protect their fuzzy white pups from predators. The mother seal leaves her pup in the lair while she dives for fish and crustaceans. Arctic foxes and polar bears often try to root out the pups for dinner. Brendan is trying to understand how flooding the snow for sea ice thickening could impact seal reproduction.
The birthing won't happen until April. So it's just a question, if you came into an area and you flooded it, say, in February, would enough snow accumulate again by birthing time for them to maintain layers?
Foxes and polar bears dig snow dens too, so they could also be affected if there isn't enough snow buildup. But the alternative doesn't look great either, given that the sea ice they live on is melting. The Arctic is warming about 4 times faster than the planet as a whole.
We've done some modeling, my colleagues and myself, and project that about 70% of the suitable habitat in terms of snow cover in the Arctic will be gone by the end of the century. So massive loss of habitat.
The Inuit residents of Cambridge Bay also rely on the sea ice for their survival. There's no highway here, only the ice. People depend on it to go hunting and fishing. Only about 1/3 of the food they eat is store-bought. When the ice recedes in the summer, the Inuit fish the Arctic char that run into the bay from lakes and streams. When the ice returns in the fall, they hunt the caribou that cross it on their annual migration. They also hunt ring seals and muskox. Some Inuit residents think sea ice thickening could improve hunting. Others aren't so sure. On weekday afternoons, community members gather at the Heritage Center in the high school library to sew fur boots and mittens and speak the local language. I came by to drink tea and ask about sea ice thickening. What's the word for sea ice in Inuktitut?
Just hiku. Hiku.
The sea ice has been forming later in the fall, which means locals have to wait longer to start hunting their food. A few have even fallen through the ice on their snowmobiles. Hundreds of caribou have fallen through too. Ice loss has slashed the local herd by 90%. That's a big deal for Cambridge Bay.
The sea ice, it's really important because we have to get to our destination to get our food sources out on the land.
That's David Hanak, a hunter who has occasionally worked as a guide for Realize. We were eating pieces of candied Arctic char, which was the color of salmon and tasted sweet and smoky at the same time. He hopes that sea ice thickening could someday help rejuvenate hunting and fishing around Cambridge Bay.
But I would say, yeah, it's a good idea to take out the water from the ocean and put it right on top of the ice to make it thicker and thicker.
But some of the elders here have their doubts. Ani Atihuyak was born in 1940 in an igloo on the sea ice. Speaking through an interpreter, she raised questions about the potential consequences.
They have mixed feelings too. We all do.
Realize isn't sure where it will try to do its 100 square kilometer demonstration. But if it's in the strait near Cambridge Bay, Annie says she'd be concerned about the underwater drones disturbing wildlife.
If they start doing that under the water, we're going to get no more fish, no more seal, no more.
Inuit activists have accused other geoengineering projects of colonial thinking. Inupiaq people in Alaska said a field trial that scattered tiny silica beads on a lake there failed to obtain their free, prior, and informed consent. Sarah Olsvig, the international chair of the Inuit Circumpolar Council, has spoken out against a proposed seabed curtain test in her native Greenland.
I would say when somebody approaches the Arctic and our homelands as indigenous peoples and say, we need your piece of land in the name of a greater good. That's exactly what happened when we were colonized.
She says geoengineering, which exists in a legal gray area, needs to be better regulated. Real Ice obtained permits from the regional Inuit government and the Cambridge Bay Hunters and Trappers organization. The company says it would do an environmental and social impact assessment to make sure the larger demonstration it plans wouldn't cause other significant harm. Let's say Real Ice continues to scale up and achieve its dream of thickening 1 million square kilometers of sea ice. If that ice could be preserved for one additional summer month, the company says it would cool the planet as much as removing 930 million metric tons of carbon dioxide from the atmosphere for 20 years. It sounds like a lot, but humanity emits about that much CO2 every 8 days. In other words, sea ice thickening won't be worth much if we don't start reducing emissions. Andrea, the Real Ice co-CEO, calls it a band-aid that would give humans time to actually heal the planet. The next question is, who's going to pay for it? Real Ice's directors have committed $5 million to research, plus part of the $13 million from the UK government. But thickening 1 million square kilometers of ice would cost an estimated $10 billion annually. Real Ice hopes to eventually get more funding from governments, like the Amazon Fund to Save the Rainforest has. Although the Amazon Fund has only raised about $780 million. So the company also wants to sell cooling credits, a kind of carbon offset. Companies that want to reach net zero targets would pay Real Ice to do a certain amount of planetary cooling on their behalf. Critics say all this money would be better spent on decarbonization efforts, like investing in solar and wind energy. In a preprint journal article, 42 top glaciologists argued that sea ice thickening and other polar geoengineering techniques are infeasible and dangerous. The scientists say these approaches could hurt ecosystems, as well as our sense of urgency to tackle climate change. Brendan, the marine biologist, is worried geoengineering could become an excuse to continue business as usual.
Even if we got the technology and the science right, will we get the social contract, the governance correct? That's really hard to imagine, that we won't get hijacked.
But he's even more worried about the geoengineering he says we're already doing by pumping billions of tons of CO2 into the atmosphere.
In an optimistic scenario, a lot of things have to line up for thickening sea ice to be a net positive for the planet, right? All the issues of scale and, feasibility and engineering and impacts on biota and timeliness. But we're somewhat desperate as a planet, I'd say.
Even if we stop emitting CO2 tomorrow, some research suggests it may be too late to save summertime sea ice. That's why Real Ice says that at the very least, we need to see if sea ice thickening works, if it might actually be able to refreeze the Arctic.
That's all for today's Friday Fascination. We'll be back on Monday with our Science News Roundup. And if you haven't already done so, don't forget to fill out our listener survey. You can find it at sciencequickly.com/survey. Science Quickly is produced by me, Rachel Feltman, along with Fonda Mwangi, Kelso Harper, Naima Marcy, and Jeff Delvisio. This episode was reported and co-hosted by Alec Loon and edited by Alex Sugiura. Shayna Posis and Aaron Shattuck fact-check our show. Our theme music was composed by Dominic Smith. Subscribe to Scientific American for more up-to-date and in-depth science news. For Scientific American, this is Rachel Feltman. Have a great weekend.